90 years ago, experiments by Professor Tolchin demonstrated the use of an impulse of centrifugal force in translational motion. The experiment was nearly successful, except when the unbalance passed to the second circle, then the deceleration of the rotation of the unbalance turned on. Thorne-Sun inertial propulsion and Shipov's inertioid were also tested, and there was rotation braking as well. This circumstance prevented the use of this principle in production. Thus, we propose the principle of unbalanced rotation, in which this inhibition is absent. The principle of inverted rotation on the second semicircle was used, which uses the rotation of centrifugal force. The device consists of a rotation motor that rotates the trunnion, sets the pusher in oscillatory motion, and a rotation mechanism in the unbalanced pulse mode. Inertial propulsion consists of 4 imbalances, aka imbalanced weights. The second imbalance is shifted by a quarter of the period, and the third and fourth imbalances rotate in the opposite direction from the first and second imbalance. Here is our research model. As it was mentioned previously, the device consists of a rotation motor that rotates the trunnion and sets the pusher in oscillatory motion, and a rotation mechanism in the unbalanced pulse mode. This graph shows the test of the impulse of the vertical force of the first imbalance within 1 revolution of the drive, rotating at a speed of 5 seconds minus 1, with the mass being equal 0.3 kilograms. This graph shows another test of the impulse of the vertical force of the second imbalance within 1 revolution of the drive, rotating at a speed of 5 seconds minus 1, with the mass being equal to 0.3 kilograms. However, the pulse period is shifted by 1/4 of the pulse period. This is done because by adding up with a period of 1, the tare of the value changes from the 0 value. This graph shows the test where we attempted to remove the horizontal component from the centrifugal force, as we rotated 2 imbalances 3F and 4F in the opposite direction. By adding the oscillation impulses, aka newtons, to the 4 imbalances, we get graphs of joint oscillations. Note that the joint graph is pointing away from the 0 position. Centrifugal force is calculated by the following formula, where m is unbalanced mass. r1 is the distance from the imbalance to the center of rotation. W is the angular velocity of rotation of the unbalance. For the calculation, we use the average value of this graph, F5, sigma, equals 3.5 newtons. If we take the angular velocity equal to 100 seconds minus 1, then F100, sigma, will be equal to the following. If we install the mover on the turntable at a distance from the center of rotation equal to 0.2 meters, set imbalances 1Fy and 2Fy on one side of the circle, and imbalances 3Fy and 4Fy on the other side, and place the second mover symmetrically to the first 2 movers, then we'll get the power developed on the axis of rotation of the turntable at a frequency of 80 seconds minus 1. Hence, according to our calculations, we will be able to generate 44.8 kilowatts. The electricity obtained from the rotation of the turntable 1 is transmitted to a synchronous generator 2, rectified by 3 and fed to the inverter 4, and the output is an alternating voltage of 380 volts. Thank you for your attention. For more information, please visit our website, ipropulsion.com.